Something you don't ever want to see is smoke bellowing out of your dash. Whether you turn on an accessory or a turn signals. Today on Tech Garage, we're going to tackle electrical gremlins, so this will never happen to you. Welcome to Tech Garage presented by Advanced Auto Parts. Today it's all about those electrical gremlins that quite frankly can be pretty scary. But no worries, by the end of this show we're going to have you so confident you can get back out to the garage and tackle any of your electrical problems. We're going to start out with the basics. We're going to use this DVOM, digital volt ohm meter. You'll be proficient at it. This is a tool that's going to make it real helpful when you get out there and check your problems. Then we got a couple problems on our truck. The first one you saw was related to the blower motor. All that smoke, we turned the blower motor off and the smoke went away. So we know it's in the AC blower motor system somewhere. We'll take a look at that. Then we're going to tackle some window problems. The passenger window doesn't work at all. Now, we don't know. It could be a regulator, it might be a motor, it could be the circuit itself. So we're going to use some strategy-based diagnosing. We're going to teach you how to do that. Last but not least, we got a headlight out. Pretty simple diagnosis, but we're also going to replace it with these spider headlights, which are phenomenal. We got a little hazing. That'll take care of that as well.
And we'll do the taillights too. This will be a highly enabling show. And you know, you can make a pretty strong argument that of all the fancy tools you have, this might be the most powerful one that can save you the most money over the life of owning vehicles. So we're going to walk through that as you mentioned. You know, it's really interesting. A lot of people get intimidated quickly when it's time to sell a vehicle or even buy a used vehicle if there's some electrical issue, because you're never really sure, at least until after today's show, whether it's part of a greater electrical problem or if it's an individual component failure. But we're going to show you exactly what you need to do to diagnose it properly, and you can save a lot of money.
Yeah, that's for sure. Keep you from trading it in. You may want to just extend the life of the car. It's intimidating, but when we get done, it'll be a piece of cake. You know, you get started with that meter, but we need to understand the basics about a blower motor. So we'll look at the trainer next.
I'm going to jump in.
Before we jump into our blower motor problem, let's review the basics: voltage, ohms, and amperage. And we can do it right here with our blower motor demonstrator. Now voltage, remember pressure, electromotive force. Really, we can measure voltage, and it's pretty simple. You just come over to your digital voltmeter, and you switch it over here to volts with the solid line and the dotted line. That's DC. The wavy line is AC voltage. So we're going to measure DC, and what we're going to do is we're going to come up, and I'll demonstrate how a blower motor works as we do this. Now, a blower motor, you turn it on, it's going to go to low, medium, and high. So what happens, it goes through a series of resistors over here that's going to step the voltage down, and then the blower motor is going to turn slower or faster, depending on the voltage. And I'll show you it in action. If I turn it on, and I put it on low, and we go across the voltage that's going to the blower motor, you can see about 3 volts, 3.5 volts going to it. Now, if I hold the leads there and I come speed it up, you can see 5 volts, 7 volts, and 10 volts on high. So you're measuring voltage going to the blower motor. You can measure voltage of all kinds of components. Now the next one is ohms of resistance, the omega sign, okay? Ohms of resistance, you just can do it right across a component. There's a wire windings in here. I go from one side to the other side of these wire windings of this injector, and it'll have a value. This one's showing about 12 ohms of resistance. Now, everything's going to vary a bit depending upon your service manual, but if it has a good ohm value, at least we know the component's in good shape. Now, last but not least is amperage. Amperage is electron flow, the current running through the circuit. In order to do that, you have to shunt your meter. So I'm going to take the meter, I'm going to move it over here to the amp spot because it's internally protecting the meter. I come over, once again, we're dealing with AC. Now to measure amperage, you have to become part of the circuit. So we're going to have to open up the circuit here. I'm going to take the lead off that you saw before, pop that off, and then what I'm going to do is I'm going to take that on one lead, and I'm going to go down to the other one. And when I turn it on, the current or amperage is going to run through the meter, and we're going to measure it. And you can see on high, we're producing about 9 amps of electricity. Obviously, if I drop it down, it's going to draw less. That's how a blower motor works. Now, let's shift our attention to what's going on under the dash. Brian has a blower motor up under there that's located here. Now, he can have a clip type, or you may just have some screws there, but you're gonna have to get up into your dash and find it. Sometimes they're a difficult job. And just pull it out, and there's your blower motor sitting in your case. Well, it's blowing the air over the evaporator or the heater core, causing the air conditioner heat to happen. Now, you may run into a blower motor that actually uses pulse width modulation. Now, that pulse width modulation, instead of that one dropping the voltage, it's just turning it off and on. It may turn it on 25% of the time. That's low. It may turn it on 50% of the time. That's medium, and it may be on all the time, which is high. But you're just going to get a pulse in 12 volts. So what he's going to do is he's going to go under there and find this purple wire going to the blower motor. This is the blower motor, and this is the actual control module, the heating, ventilation, and air conditioning control module. Now, what's happening is the driver's given this control module inputs, and it's sending voltage over to this blower motor. So if Brian goes under there and finds a purple wire and a black wire, switches it on, and we have voltage, we know his blower motor is the problem. If he doesn't have voltage, well, strategy-based diagnosis. Just back on up, check it at the module. If it's coming out of the module and it's not getting to the blower motor, he knows he has an open wire right here. If it's not coming out of the module, that means we have to go over to the other side and find out why it's not getting the inputs. Brian's tackling the electrical problem on our pickup truck. We'll see what he found out as soon as we return with more Tech Garage.
This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by McGuire's since 1901. Stage 8, the world's best locking fastener. Steel Rubber, quality crafted rubber parts and weather stripping. And by Advance Auto Parts. Let's get you back to the garage.
Welcome back to Tech Garage, presented by Advance Auto Parts. Well, if you're like me, especially as I get older, getting up under the dashboard can be a challenge. You got to twist and turn, and getting access to things is always a fun game. I checked on the MotoLogic website to see where this blower motor was that we think is the suspect here. Remember, it didn't work when we tested it, and we know we had smoke and the smell of electrical burning. So I'm going to head to the blower motor. I had to take off one panel, 7 or 8 bolts, wasn't hard to do, a few hand tools, and I got my voltmeter inside. So let's see what that blower motor is doing or not doing. Okay, with a flashlight, I could get a good look right where MotoLogic said, there's the power connector, there's the blower motor, there's the twist lock. So step 1 is get that power stub out of there. Pops right out. Now let me twist lock this blower motor and get it released and come down out. Now, keep in mind, John mentioned there was a purple and a black wire. There's a purple and a black wire. We're in great shape here. So, we're going to test them. We're going to see if there's power. Remember, the key is in the run position. We're going to test for power, red to purple, black to black, which is ground. And once I get these probes seated in here, I can turn the blower motor on, but not on low, actually to high. I want full potential, or all the voltage coming through that switch to this circuit. That would put the fan on high if it was working. Look at my voltmeter, and I ought to be right between 11 and 12 volts. And sure enough, I'm at 11.1 right there. So we've got full power coming through the circuit here, but the motor itself isn't spinning. So I think the motor's a candidate. We're going to go ahead and swap it out. Back this off. I'm going to turn the blower motor switch back to off. And out with the old, and in with the new. So the blower motor here has the same connector. You just want to validate that. And we'll do one more inspection before we do the final install. But it goes up and in, and I think this is going to be very simple. So the new blower motor comes in here. And I'll tell you what we're going to do. We're going to validate with the meter. We know we've got 12 volts coming to here. We're going to validate this is working and that the other motor was the problem. I'll connect it and pre-connect it. Now this time I'm going to get a good firm grip on this. I don't want to jump it out of my hands. And I'm going to turn the blower to low. We should have power right here. And we do. That old blower motor was in fact the problem. No more smoke and smell in here. I'm going to get this replaced, get it back up and in, and I'm going to do one final inspection. Remember all that smoke? You want to make sure there's no charred wires, nothing's burnt, nothing's a problem in here. So one final inspection before I reinstall it. And I think John said something about a window problem. This guy's going to be next, but first we better understand exactly how a power window circuit works.
Now, Brian's right. It's always a good idea to understand the circuit, how it works, before you dive into doing any kind of measurements. And ATEC sent us this power window system, lays it all out. Only on Tech Garage you're going to see a power window system wide open. You actually have the power window motors. They're right here. And then your switch you operate is located right here. You just hit it and it operates the motors. But how it operates the motors is pretty cool because it does it bidirectionally. How does that work? Well, it sends 12 volts up to it, it goes through the motor and it returns to the switch to ground. I know that sounds complicated. We'll look at it in the schematic in a minute. Most window motors operate the same way. You hit it one way and hit it the other, and I can show you how it operates properly, then we'll open the circuit and I'll see what happens when it's not operating properly. So if I come over, you can see this is working just fine. But if I unplug it, and then I come over with the meter and I got it on volts, and I'm going to go across the two leads that go to it. Now remember, I said it's going through the motor and it's returning back to ground. So what we're going to see is I hit the switch, you can see you got 12 volts, and if I go the other way, it's an actual negative 12 volts. So it's reversing the polarities and it's allowing the motor to go up and down. Now if I plug it back in, you can see it's actually auto running there, just like you hit the button in your car, and then it stops. It can stop over a given period of time, or it can actually sense the amperage. When your window gets to the top and starts to bind on that motor, it'll open it up. Now, if I want to open the circuit, I can do that real easy. I just come here and open it up. The board's going to short it out and open it up internally. That's an open circuit. We're not getting anything to it. So what happens is, first of all, it's not going to work. That's our case. Now, if I unplug it, what's going to go on? If I go ahead and I go across my connector, okay, and I hit the actual, you see nothing on the meter, nothing in either direction. That means we have an open circuit somewhere in the circuit, the switch or whatever's going on, but we don't know if the window motor's good or bad. If we had the 12 volts up there, the window motor's bad. Now we can take a look at the schematic that's actually dealing with our truck. Brian's dealing with this exact motor and this exact switch. So here it is right here. We start out right at the top here. It feeds 12 volts through a circuit breaker. It comes down to the switch. Now that's the easiest thing to check. It's right in the door panel. You can pop that off. You can check 12 volts going into that. Then you hit the switch on the other side. I should have that positive and negative voltage coming out. I go all the way down to the motor. The motor's located in the door panel. So what we want to do is tear the door panel off, which I believe he's doing right now. You can see he's going to have a dark blue wire and a brown wire, just like we did on our board. If he takes his voltmeter and he goes across those two leads, hits the switch with everything plugged in, and he sees a positive and a negative 12 volts, well, we know everything up there is good. It has to be a window motor. Strategy-based diagnosis, just go back. 12 volts there, bad window motor. No 12 volts, and open. No 12 volts, a switch. It's real simple. Just take your meter, take your time, work up your circuit, understand your circuit, and you'll be able to tackle your problems. Brian's digging deep into that window circuit. We'll have more when we return with Tech Garage.
Welcome back to Tech Garage. We know we have some type of intermittent power window issue here. I got looking at the MotoLogic scheme and I saw there's 5 10mm bolts that hold this panel in place. And you know what? This could end up being a pretty big job if we don't try to do some troubleshooting out here on the front end first. I'll pull that off if I need to, but I first want to check this switch. Now, I did the famous thump test, and that's an official automotive term. You know, you thump the door to see if that makes the window motor work. We got it up, we got it down, we got it partway back up, and then it stopped. So we may have an issue here in the switch, honestly, if we're lucky. Now there's 2 bolts right here. I'm going to get them removed and get this strap out of the way. Just be gentle here. All this is a friction fit. It pops off, 10mm, and we go ahead and back these out. And that's going to let us lift off this modular piece that holds the switch. And there's 2 connectors back there. One's for the power lock, and one's for the power switch for the window. So this strap comes off. Set it right in here. Now, when you're dealing with removing any pieces from a door panel, take your time here. You don't want to do any damage. You got to look at a door panel for a long time, the life of the vehicle. So I'm just going to gently work this up. And again, the MotoLogic schematic really helped here. Helped me understand this is modular. So it's going to lift that up. Now, we should have a plug coming to the power window switch and a plug to the power lock. I'm going to lift that up. There may be the culprit right there. That plug does not appear that it was seated down in there and latched. It should not have fallen off. See, the power lock one stayed in place. So that may be our problem, in which case I'd be happy I didn't pull this whole door panel off. But let me test that and see. So we've got the key in the run position, so we know we should have power coming into this switch. So we're going to find red and black, which we've got. And so we should get close to 12 volts here from the power supply coming to the switch. So red to red, ground to ground, and there we have it, 10.5 volts. So we definitely have power coming through this circuit. So I'm willing to bet that it's a connection issue coming into the switch. Now, if you were to plug this back in and the window lift motor still didn't work, then you'd have to chase your power supply from the switch down to the motor and see where the problem is. All right, it latched, I felt it. Now, let's go ahead and test the window. Down. A meter out of the way here. And up. That would be the 12 volts. Negative 12 John talked about. Go up. No issues. We got lucky on that one. We dodged a bullet. Again, it's a big job if you got to pull this door panel off and swap the motor, the regulator, and all the hardware in there. You got to be really careful what you're working with and understand exactly all the implications of the project. Checking my latch here. I'm going to check it on the power lock while I'm here. It's good. We're going to get this button backed up, and I'm excited we've got the window working. We're going to get this seated right back down in here where it belongs. And I do believe that John's up at the front of the truck with some pretty cool work going on.
We've been working on the headlights. We got one spider headlight in, and it's time to do the other one. But let me bring you up to speed. We just took the grill off. That was pretty simple. I had to pop the plate off here that actually covered it. Then I took a few bolts out the top, kind of just had some clips down here, gingerly popped it out, grill sitting there ready to go. Got good access to the headlight. Now these are composite headlights, so I'm gonna have to take the whole unit out of there to replace it. It's a little 10mm down on the side, a little flexible ratchet, and it's got a slide clip, so I got that loosened up. Now I'm just gonna take the rest of the bolts out. There's about 4 bolts here. There's 2 at the top. That one, and then I got these 2 here. And there's actually a bracket over here that's holding it on. So I want to be able to slide it out with the contour of the frame. So I'm just going to go ahead and take this bracket out of the way. Make it a little bit easier. One more down here. Now that bracket will slide out of the way. And then what I need to do is just gently work it out of there. You got to be careful. You're talking about the paint and the frame here, but with a little persuasion, you should be able just to slide it right out. There it goes. Just look at the paint, make sure you're good there. Everything's fine. And then I got one connector back here. Just disconnect that. And once I got that disconnected, I can go ahead and pull the whole assembly. That's a composite headlight assembly. I can pull it over here to the bench. Now, once I got it on the bench, we can take a look. It's gonna be pretty easy at this point. What I did is I just take the wire harness from this one and I transfer it over to this one. They give you 2 plugs, really nice hookup here on Spider that will actually plug in the high beams and the low beams right into the existing wire harness. And then you see here, the only thing we have to do is besides those 2 plugs, is we have to take the power and the ground for the halos. And what I'm going to do is we looked earlier at the schematic on MotoLogic, and I'm going to tap into the parking light circuit, because that'll be pretty cool. We turn on the lights, the halos are going to burn. So I'll tap those in, we'll get it buttoned up, we'll get a little bit further on the grill, and we'll let you take a look at it as soon as we return with more Tech Garage.
This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by Dustless Blasting. It's the future of surface preparation. Precision Turbo, the world's foremost manufacturer of high-performance aftermarket turbochargers. Spider Auto, specializing in automotive and truck accessories. And by Advance Auto Parts. Let's get you back to the garage.
Welcome back to Tech Garage. Now we got the front end of our pickup truck all buttoned up and it's looking good. Spider headlights, no big deal. Few wires, swapped them over, got it plugged in. It's looking really good. We also put in the rear taillights were LEDs. Plug and play, 2 screws in the bed, popped it in, looking sharp. Now let's give these ones a test drive. Go ahead and kick them on. Man, they look great. These projector beams are not only looking good, they're functional. We're gonna see a lot further ahead. Truck's gonna be a lot safer. One other trick, we couldn't bear putting that grill back on, so what we did is Putco sent us this Boss grill, and this is gonna finish off our Edelbrock supercharged truck. Our project is about complete. It's looking good from the front to the back. All we have left is the email question of the week.
John Tyler from Knoxville, Tennessee wrote us. He had a Chevy Malibu that had a fogged up headlight once upon a time. He replaced it, no big deal. Now he's driving a Lexus. That's a very expensive replacement. He wants to know what are his other options to clean up that lens.
Well, the Spider is the ultimate option, but we have a few more for you. You can look at the Meguiar's restoration kit, nothing to it. 1, 2, 3, sand, buff, and then protect it. You're good to go.
And these are expensive assemblies. They have articulating beams in there. So if you're going to trade the car or sell the car anytime soon, you may not want to invest in a whole headlamp assembly. Meguiar's makes a really nice solution for this. If it's not too bad a shape, you clean it off, you seal it, it creates an epidermis on the outside, so the same problem won't happen again, and that is how Tyler can restore all of his headlight power.
Well, folks, this whole season's been about power and performance. And speaking of power and performance, we have with us Jose Batista. He's from the Blue Jays. He's a current alumni here from Chipola, and he was kind enough to visit us. Jose, I know you got a supercharged car, and you're all into cars.
Yeah, power and performance is what I like in my vehicle. So I know when to punch it and when I can, enjoy it within the laws of the state of Florida. So I enjoy my car, and I like getting the most out of it. So fine-tuning is something that I've been a part of for a long time, and it's something that I enjoy. So you guys have done a great job. I've been watching and having a lot of fun doing so.
Well, thank you. I appreciate that. Well, you've seen it here. Jose Batista on Tech Garage. Thanks for watching. From our garage to your garage. Thanks for watching Tech Garage.
Production assistance for Tech Garage is provided by Chipola College, located in Marianna, Florida. Founded in 1947, Chipola College is a member institution of the Florida College System, with a current enrollment of over 2,000 students. Chipola offers bachelor's and associate degree programs, as well as college credit and workforce development certificates. Chipola was recently ranked as one of the top 3 community colleges in the United States.